Okay, well, today we are going to talk about moment. What is moment? What is moment? Well, moment, you typically use it as like momentum, right? I mean, sort of similar, but in statics or in civil engineering, moment is number one, vector quantity. Two, the formula, or the the simplest way to say I'm gonna define a moment is the cross product between R and F. Well, what is R? R is the distance between the applied force, or the exerted force, and the moment, or the point of interest. What does that mean? You have this beam, for example, and you've got a force somewhere here with a distance, and for some reason you're trying to find the moment at A. What you need to do is you multiply the force by the distance, and that's the distance that we're talking about. I'm not trying to give you a lot of theories, as I promised. I'm trying to give you the useful information. But still, if I ask you, or someone randomly asks you, what is the moment, or how you define moment in statics, so that's how you define it. The multiplication, or the cross product between the r vector, or the distance, or the arm vector, and the force vector. So, today we will be talking about moment. And pretty much I summarize all chapter 3 in Beer-Johnson book, 11th edition. And I'm assuming that all of the editions. So, the moment class, or the way I'm going to do moment, I'm going to do a small, really 5 minutes hopefully, or 7 minutes max, general idea about moment. And then the next video I'm going to solve moment and introduce 3-dimension moment. I'm not going to focus on 3-dimension moment a lot. I'm also going to solve a problem on 3 dimensions. So that's how the agenda is going to look like. 1, intro to 2-dimension moment. 2, it's going to be examples. 3, and probably introduction to 3-dimension. And then 3, it's going to be 3-dimension example, and maybe more 2-dimension. So again, just to recap, moment is force cross, or the arm vector, cross it with the force vector. And the simplest way is to do it, make, if you recall, the cross product. You could make the cross product to be like this. Sine alpha. Alpha is defined by the angle of separation, or angle between the arm vector and the force vector. It's just, depends on nomenclature that you're following. This, if it's 90, what are we going to have? We're going to have just this. And that's how I'm going to teach you moment. So if you have something like this, just hypothetically, here's your force, P. I want you to do Px and Py, and then you multiply that by the perpendicular arm, which is for, if you move this Px here, this is your perpendicular distance, A, to point big A, and then your perpendicular distance to Py with respect to A is going to be this arm, B, let's call it. So your moment is going to be, for example, at A, sum the moment counterclockwise positive, it's going to be Px times A counterclockwise, because you're putting, here's your P going to A, so that's counterclockwise. Here's your force, here's this, so that's going to turn it counterclockwise. And then your Py times B, it's going to be clockwise. Just hypothetical example. So you don't need to do angle of separation. You do this, here's your arm, here's this, and you start finding out what is this angle and what is the angle of separation. No, that's not what we're going to be learning. That's one of the philosophy that some people do it. Just try to make the angle of separation between the point of interest and the exerted force to be 90, which is the common one. That's what I'm going to teach you. Some people will do it sort of mathematical approach, calculus 3. So that's pretty much it for this video, and we'll see you hopefully next video about examples and 3-dimension, and then we'll do another one, and that should do it for chapter 3 for this week. I'll be sending some homework assignment, I'll be sending some agenda for my students to see what we'll be doing every single week. I'll sign off for now. We'll see you soon. Peace.